Hello everyone. In this lesson, we want to estimate the area of a curve using small rectangles, no more than 10. So the curve will be y equals f of x on the interval, closed interval AB. And these are the steps that we will use. One, we want to calculate delta x. Delta x here will be the length of the base of the rectangle, and we find delta x by solving b minus a over n, where n is your number of intervals. Then we want to write a list of subintervals in the interval AB, and they can be listed like a plus delta x, a plus delta x, a plus 2 delta x, and so on, all the way up to a plus n minus 1 delta x, b. Then we want to evaluate each point on the subinterval. That is, for each endpoint that we choose, we want to plug that into our f of x function. We're going to call each of those c. So we just say it's f of c. And so we're going to plug each evaluation point into the rectangle, and our area will be equal to f of c times delta x, where f of c is our height, delta x is our base. And then we add up all the values found in step 4 to estimate the area under the curve. So the area under the curve will be estimated by summing the areas of the rectangles, right? So let's look at a couple of examples. In this example, estimate the area under the curve f of x is equal to 4 minus x squared between x equals 0 and x equals 2 using endpoints. Left endpoints is very important because we can use left endpoints or right endpoints, or even endpoints in the middle called midpoints. Okay, and we want two rectangles with width 1. So the best way to put in two rectangles of width 1 would be right here. There's one from 0 to 1 all the way up, left end hitting the curve, from 1 to 2 all the way up, left end hitting the curve right here. So your interval AB, closed interval AB, be equal to the interval 0, 2. And here is 2 because it said that we will need two rectangles. So that is why n equals 2. Then we want to find delta x. Delta x will be the width of our rectangle, even though it was given in the question. Even if it was not given, we could use a formula, the b, which was 2, minus a, which was 0, over n, which was 2. Okay, so that is one way of getting back to 1, even though the question told us the width was 1. Okay, then we want to divide this into subintervals, and we're doing it this way. It might seem pretty simplistic, but the good thing about doing it this way is that you can see where each interval starts and ends, right? And wherever one ends, that is the starting point of the second. So wherever the first one ends, that's the starting point of the second. So this is not a jump. It is exactly the starting point of the second, as you see here on the graph. Where the first one ends, the second one starts, okay? And we separate it out by this way. So here you can see the left endpoints directly. As you do more of these, you might not want to write them all out like this. You can see it's 0, then 1, then 2, and then you can just start at the left, and then the right endpoint of the first will be the left endpoint of the second, and so on and so forth. But for right now, it's nicer to write it this way because now you can see the left endpoint in each subinterval. So we want to evaluate the function at the left endpoint of each subinterval. So we're doing the f of 0 and the f of 1, because f of 0 is the left endpoint of the first, and f of 1 is the left endpoint of the second subinterval. So then we're going to plug these into our formula, f of x formula, and we knew that our f of x formula was 4 minus x squared. So this is equal to 4 because that's 4 minus 0 squared, and f of 1 is equal to 3 because it's 4 minus 1 squared. Now we want to find the area of each rectangle, which is delta x times f of c, which is the base times the height, base times height. So the base is 1 and the height is 4, so that's 1 times 4, which is equal to 4. And for the second rectangle, the base is 1, the height is 3, so that's 1 times 3, so the area will be equal to 3. And then we sum these. We sum all our delta x's times f of c's, and that would be 4 plus 3, 4 from the first rectangle, 3 from the second rectangle. 4 plus 3 is equal to 7, so our area is equal to 7. Now you want to say 7 units squared, that's fine, but area is equal to 7. Areas that we are calculating, they are estimates for the area under the curve. So in the first one that we calculated, that was an estimate for the area under the curve. Okay, and let us look at this. Estimate the area under the curve. 4 minus x squared f of x is equal to 4 minus x squared between x equals 0 and x equals 2, using midpoints and two rectangles of width 1. We know that our delta x is equal to 1, and we know our subintervals, because they are width 1, then we can write out those subintervals 0 to 1 and 1 to 2 again. However, we are now using midpoint, so we have to find the midpoint between 0 and 1, that is 0.5, and take the height of your rectangle where x equals 0.5 meets the curve, right? So at 0.5, f of 0.5, that would be the point where the height of the rectangle, the highest point that the rectangle can go, is right there. And then also take the midpoint between 1 and 2, that would be 1.5, and sketch your triangle at the point 1.5, f of 1.5. So that is what our new areas look like. Our new two triangles look like. Okay, now your subintervals are still 0 to 1 and 1 to 2. Okay, the closed intervals 0 to 1 and 1 to 2. Subintervals 0, 1, 1, 2. So I want to evaluate the f of 0.5 and the f of 1.5. Why? Because these are our midpoints, the midpoints between 0 and 1, and midpoint between 1 and 2. And so the f of 0.5 is 4 minus 0.5 squared. 0.5 squared is 0.25. 4 minus 0.25, that is equal to 3.75. So the area, it's not the area, the height of this first rectangle is 3.75. Now the f of 1.5 would be equal to 4 minus 1.5 squared. 1.5 squared is 2.25. 4 minus 2.25 will give you 1.75. And then I want to evaluate the areas now of these two individual rectangles using a formula, base times height, or delta x times f of c. That'd be 1 times 3.75 because the base was 1, the height was 3.75, so that gives us 3.75. And then for the area of the second rectangle, that's 1 times 1.75 equals 1.75. And then we want to find the total area made by areas of the two rectangles separately, which would be 3.75 plus 1.75, and that is equal to 5.5. So this 5.5 is our estimate for our area under the curve. 5.5 is our estimate for the area under the curve. Let's do a third example. Estimate the area under the curve f of x is equal to 1 over x squared between x equals 1 and x equals 4 using right endpoints and 5 rectangles of equal width. Okay? So use the graph of f to explain whether your estimate is an overestimate or an underestimate. So then let's first find our delta x, or what would be the width of your subintervals, which will in turn be the base of your rectangles, base of each of your rectangles. So delta x would be b minus a, which is 4 minus 1, over n, which is 5. So this, in this case, n is equal to 5. 4 minus 1 over 5, that gives you 3/5. Then let us write our subintervals again. In this video, we are writing out each of the subintervals. So let's do that. So now we have 5 subintervals, 1 to 8.5, 8/5, I'm sorry. 1, you can see 1 as 5/5 as well. If you want to write 1 as 5/5, that's fine. 1 to 8/5, 8/5 to 11/5, 11/5 to 14/5, 14/5 to 17/5, and 17/5 to 4, right? Or if you want to write that as 20/5, that's fine. Okay, now let's evaluate f at each of the right endpoints. What are right endpoints? 8/5, 11/5, 14/5, 17/5, and 4. So f of 8/5 is going to be 1 over 8/5 squared. You can invert that to become 5 over 8 squared. And then f of 11/5, that's 1 over 11/5 squared. It's going to be 5 over 11 squared. And f of 14/5, 1 over 14/5 squared. That's going to be 5 over 14 squared. F of 17/5, 1 over 17/5 squared. It's equal to 5 over 17 squared. And then f of 4 is going to be 1 over 4 squared. That's going to be the same 1 over 4 squared, right? And then we want to do x times f of c, which is the base times the height of each of these. And then we're going to sum them. Let's just do the sum. Just do it in one step this time. That's going to be 3/5 times 5/8 squared plus 3/5 5/11 squared plus 3/5 times 5/14 squared plus 3/5 times 5/17 squared plus 3/5 times 1/4 squared. And that is a little bit of a bunch of arithmetic there to expand out. We can do that, or we can just say, okay, put in your calculator, and it returns 0.524. Okay, it's 0.524. So we want to say, okay, is this an overestimate and an underestimate, or an underestimate of the area of the curve? And we say it's an underestimate of the area of the curve because if you observe, it is less space. It takes up less space than the area under the curve there. If you notice, they will have some extra spaces above the rectangles, or some people might see white spaces above the rectangles if you shade in the rectangles. So therefore it is an underestimate. Thank you very much for watching, and see you next lesson.